Hello everyone. Welcome to this video. I'm Keshav and I'm here to present the construction and working of telescopic dampers. So this is a part of automotive systems course and its assessment. So let's get on with the presentation. So telescopic dampers are mechanical devices that helps us in transforming the kinetic energy of a vehicle into the potential energy and getting rid of this potential energy in terms of heat. So commonly they are also referred by the term shock absorbers since they reduce the effect of bumps on roads and by absorbing the sudden shock created by the bumps and manholes. So coming to the construction part, the word telescopic very much tells us about the geometry of the device. So there are two coaxial parts. The outer one is definitely a tube, but the inner one may vary. It can be a tube or it can be a rod. Then we have valves in this, and then we have two mounts that we call as eyes, and we have the tube which is filled with fluids. So we have hydraulic fluids in this, and this hydraulic fluid is made up of transformer oil and turbine oil. And also talking about the valve, this valve is a two-way valve in which the fluid can travel from both the directions. So there are two types of telescopic dampers. The first one is called twin tube telescopic dampers, in which two tubes. And in the monotube telescopic dampers, we have a tube and we have a rod. So this is the basic difference between these two dampers. So coming to the construction of twin tube telescopic dampers, as you can see in this figure, we have I1 and I2. The I2, that is the lower part, is generally mounted on the axle of the wheel, and the I1 is fixed to the body. And then we have a shell case, we have the rods, we have a tube. In this twin tube telescopic dampers, we have two tubes, and in and we have two valves. So we name them piston valve assembly A, piston valve assembly B. So just to note that both these valves are two-way valves. So and then we have another photo here, image. So it's telescopic body, and then we have valves, and then we have pistons. So coming to the monotube telescopic dampers, we have I1 and I2. This is same, that I2 is connected on the axle and the I1 is connected on the body. Then we have a shell case, we have rod, and in the major difference comes here, as in this, as we have only one tube, and in this we have a free piston. We have only one valve in this two-way valve, and we have only one valve, and then we have a free piston that is movable, and the chamber between the valve, no sorry, the valve and the piston is filled with fluid, hydraulic fluid, and the portion below this free piston is filled with the gas at high pressure. So talking about the main components, we have rod, we have oil seal, we have pressure tube, we have hydraulic oil, then we have high pressure gas, we have floating piston and piston valve assembly. So these are the parts of a monotube telescopic dampers. So this is a live example of a Star City bike, TVS Star City bike. These are the front dampers. As we can see, this is the outer tube and this is the inner tube. And I'll be showing you a video. So let's see it here. So when you can see, when acted upon by force, this inner tube gets inserted within the outer tube. I'll just repeat it. So this is the process of shock absorbing in a twin tube telescopic dampers. So this is another telescopic damper. This is a monotube. As you can see, within the spring we have a rod, and then we have a tube. So the spring here acts as as the creator of force that pushes the rods outwards when we pass the bump. So talking about the working of monotube, you can see that uh, when acted upon by force, it gets compressed, it gets inserted, and then yeah. So the working of twin tube telescopic dampers, When the vehicle comes across a bump, the lower eye tends to move upwards, this valve A moves downward and the fluid gets compressed. So when the fluid gets compressed, it tries to move out of the chamber, and it has two paths, through valve A and through valve B. So coming to this figure, as we can see, when when first, let us see first see the compression cycle. During compression cycle, the pressure here increases, the fluid starts moving. So it has two paths, one through the valve B, the base valve, and then we have this valve A and valve B. It moves through both these valves, and then we have another path that goes to the region between the two tubes. So this is the compression cycle, and during the extension cycle, uh, the pressure is higher on this side, and thus fluid moves into this chamber. So this is the working of a twin tube telescopic dampers. Now the above process converts the vibration energy into the fluid friction and compression, and thus we say the energy is absorbed by the fluid. Now during the reverse action, the valve A moves upwards, thus pressurizing the upper chamber, and so fluid moves into the region below, and some fluid from annular region also moves into the chamber. So we have two paths. So coming to the working of a monotube telescopic damper, upon coming across a bump, the I2 moves upward, thus the rod piston moves into the tube, compressing the oil chamber. And the floating piston as a result moves downwards and compresses the gas till the oil pressure and gas pressure becomes equal. So as you can see in this picture, when acted upon by a bump, the pressure here, because this eye is fixed to the axle, and this upper end of the rod is fixed to the body part, so this compresses when acted up by a force. So this compresses, so naturally the pressure here increases. So when the pressure increases, we have this movable piston that can move, and we have a high pressure gas on this side. So pressure of the fluid and pressure of the gas, so when these two can equate, when these two can become equal, so at that point uh, starts to decelerate, and thus a shock is absorbed in this way, in this device. So let us continue here. The vibration energy of bump gets converted into the heat energy and dissipated by the oil and the gas. And in the reverse action, the piston rod assembly moves upward, reducing the oil pressure. Thus, the free piston moves upward to equalize the oil and gas pressure. So this is the working of a monotube telescopic damper. So coming to the advantages of using telescopic dampers, we have noise-free operation. Because we don't have too much of parts, we only have fluids and springs that are mostly working in this, and we have low maintenance requirement because of the intact assembly of this. Yeah, we can have some oil leakages, but if we clean the vehicle properly, if we take proper care of it, no, this problem generally doesn't occur. So the manufacturing and assembly is easy, and it can be operated at varying speeds, and it can be easily adjusted depending upon the level of comfort that we need. So these are the advantages of using telescopic dampers. Well, thank you for watching this video. I hope you like it.